Hello, Golden Valley. Thank you for checking in with me again today, and I want to thank those of you who have been liking Mr. Sargent's ties down in the comments below. I appreciate it. This is one of my favorite springtime ties, so it's got a very springy feel, so hopefully it'll get some likes. We're going to talk a little bit today about some circles, and then there's a Google form for you to complete that is due on Friday. We're going to start off by talking about what's called a central angle. A central angle is an angle who has a vertex at the center of the circle. So the central angle that we are looking at here is what's called angle A, B, C. And this is because the vertex, the middle part of the angle, is located in the center of the circle. This is called a central angle. Now I'd like to refresh you on some things that you don't learn in school, some things that you already know. If you go all the way around a circle, in other words, if you go like this, that's called a 360. Everybody knows that. And likewise, if you go halfway around a circle, that's called a 180. And that's the number we need today is a 180. When we look for what's called a minor arc, we're looking for an arc that measures less than 180 degrees. So notice if I start here at C, and if I were to go all the way around to D, that's a complete 180. So an arc that's less than 180 would be if we walked from C to A. So this arc up here is what's called a minor arc. And I'm going to use this symbol and call it arc AC. There are other minor arcs in this circle, but we're going to move on and talk about a major arc. A major arc is an arc that measures more than 180 degrees. So in other words, if I were to start here at D, and go all the way around to C, that's 180. But if I continued further to point A, that would be more than 180 degrees. So the major arc is what we call arc DCA. A major arc always requires 3 points to name it. We also could have said arc DEA as well. This is a major arc. Now a semicircle is exactly 180 degrees. So I can start at C, go to A, and continue to D, and I'm going to call this arc CAD because this measures a full 180 degrees. There's another semicircle in here called arc DEC, but we don't need to write that down. We're just trying to be quick today. So let's go ahead and include some values. Let's include some values on this circle. For example, let's call angle ABC. Let's call this 57 degrees. Then we will use that information to calculate the measure of arc AC, the measure of arc AD. The M just means that we want to know what's the measure. We just want to know the degrees. So the measure of arc DEC and the measure of arc DEA. So let's start off with some basics. The first one is the measure of arc AC. Well, the measure of arc AC is this arc up here, and it is the same as what the central angle measures. So this arc AC measures 57 degrees, the same as the central angle. Now let's look at some things that we know. We know that this angle and this angle create a linear pair, so we know they add up to 180. So if we do some quick calculations and we do 180 minus 57, we are going to end up with, let's see, this is 7, 3, 123 degrees. Again, this is a linear pair. So if I look at the measure of arc AD, that's this arc out here, well, the arc should measure the same as the central angle, so we get 123 degrees. For the measure of arc DEC, well, notice that D is the end of a diameter, C is also the end of a diameter, so we have what's called a semicircle. A semicircle always measures 180 degrees. And the last one we see here, the measure of arc DEA. We start at D, we walk to E, we go all the way, well, I just noticed that I've gone 180, but as I continue past C, I go an additional 57. So we're really doing 180 plus 57. And we work this out, and I believe that we get 237 degrees for the measure of arc DEA. Again, today you have a Google form. Please complete the Google form. Do the best that you can. Remember to check in, I think, on Wednesday for your next assignment. We'll see you later, Golden Valley.